Hi everyone, welcome back to yet another Euphoria Academia YouTube video, where we do past papers and we reveal some tips and tricks on how to solve these questions. Today we're going to be doing the grade 12 Physical Sciences paper 1 that was written in November 2022. My name is Ole and I'll be taking you through it. Let's get into it. Today we're going to be doing question 3, which is about projectile motion. So it starts from question 3.1 and it ends at question 3.3, and it is a maximum of 16 marks. So let's just see what we have in store for us. So we are told that a ball is thrown vertically upwards from the top of a building which has a height of 25 meters with a velocity of 12 meters per second. On its way down, the ball passes a door which has a height of 1.9 meters, and then it strikes the ground as shown in the diagram. And I'm told to ignore the effects of air friction, which tells us that we are dealing with projectile motion. Okay, so we have a ball on top of a building, and this ball is actually going to be thrown vertically upwards with some initial velocity 12 meters per second. Now it's going to be going up until it reaches a maximum height where the velocity will be 0. Now after it reaches that maximum height, it's going to fall to the ground up until it passes a door at 1.9 meters and it will eventually hit the ground. And just like that, that's our problem. Now, question 3.1, we are asked to define the term freefall. Now, freefall is a situation where the motion of an object, I guess, is under the influence of only, this is the most important part, gravity, or let's just say the gravitational force. For question 3.2.1, we are asked to calculate the time taken for the ball to reach its maximum height. Now, as stated in the problem, we know that at the max height, our velocity is 0 meters per second, and we are told that our initial velocity is 12 meters per second, and the acceleration is and will always be, unless stated otherwise, 9.8 meters per second squared. Now, I am going to take downwards as positive. And today I'm feeling like being a rebel, which means that this acceleration due to gravity is acting downwards, so it will be positive, while this initial velocity is pointing up and will be negative. Alright, so let's just see which formula we're going to use. We're going to use Vf is equal to Vi plus the acceleration multiplied by delta t. Now our delta t is essentially from 0 to some time t, so I'm going to drop the delta, right, because our final is essentially going to be t minus 0, and that is going to just give us t, right, in terms of delta. Right, now our final velocity, as stated, is 0. Our initial velocity is 12 plus, oops, I almost forgot something. Initial velocity is negative. It is negative because it's pointing upwards, and our acceleration due to gravity is 9.8 multiplied to our time t, and when we do some maths we will see that our time t is equal to 1.22 seconds. For question 3.2.2, apologies for the delay, we are asked to find the velocity with which the ball strikes the ground. Alright, so we're meant to find the velocity at the ground. Okay, so essentially we have to find like some piece of information, right? So we already know that at the maximum height of the ball, the velocity is zero. Velocity is zero, but as it travels to that maximum height, just call that max, it has traveled some distance here, right? And we already know that the height of the building is 25. So if we can find this distance here, we essentially will use our velocity there, which we'll call VI, and then the velocity at the bottom will be VF, and we just need to find what this height is, and we can use our equations, right? Because essentially now we just have two unknowns. The unknowns being the height, and then the other unknown is this VF. Alright, so let's find that height that it has traveled. Okay, so we're going to be using VF squared is equal to VI squared plus 2a delta y. Now I'm still taking downward as positive. Now our VF squared at this maximum, this is the maximum height, the velocity at the maximum height, that's going to be 0. And then our VI is still the 12 that we were told to work with, and then that was going to be multiplied by 2. This 12 is negative, by the way. This a is positive, and our delta y in this instant, we're taking our yf, that's our final displacement, minus, we'll use the reference frame that this is going to be 0, so I'll just find this yf and drop the delta. Alright, now after doing some maths, we find that our yf is actually equal to 7.35 meters. Alright, and this 7.35 meters is actually up, right? So in terms of displacement, this would be negative, but in terms of magnitudes, it's just that. Alright, so the total height above the ground, right? The height above ground is this 7.35 meters plus the height of the building, which is 25 meters, and that is going to give us a total of 32.35 meters above the ground. Alright, now let's find what our final velocity is. We're still going to use that equation that we started with. Vf squared is equal to Vi squared plus 2 a delta y. Alright, now in this case, our delta y is actually going to be positive because we're traveling all the way down. Right, and our acceleration is also pointed downwards. This is the only negative that we're going to get. Alright, so Vf squared is what we're trying to find, and we're moving from the maximum height where Vi is equal to 0 plus our 2 multiplied to 9.8 multiplied to that total distance above ground, 35 meters. After doing some maths, we're going to find that our Vf is equal to 25.18 meters per second, and it is pointing downwards. Alright, for question 3.2.3, we're asked to find the time it took the ball to move from the top of the door to the ground. Alright, so we're in this reference frame where we want to find the time it took from this top of the door to the ground. Right? How long did that take in terms of seconds? Right? Now, what would be helpful is if we had a velocity here. We already have a velocity, final velocity there, and we already have an acceleration. So if we had that Vi and that we have the Vf, then we would essentially use the equation that our Vf is equal to our Vi plus acceleration delta t, and we just need to find this time t. Alright, so I guess that should be our mission right now. Our mission is to find that initial velocity, right, to make things easier for us. Alright, now how do we find that initial velocity? Well, we know that the ball would have traveled to the max height, and this max height is equal to that 32.35 meters above the ground, and the velocity at this max height is still 0 meters per second. These are things that we know, that we have calculated. Alright, now how will we find this Vi? Well, essentially that Vi will be that distance or the velocity that the ball will have after it has traveled from that 32.35 to a point where it reaches the top of that door. So we essentially need to find this distance here. Alright, so what is that distance? Well, that distance algebraically is just let's just call that distance downwards from max height to top of door. Right, that distance is just 32.35 meters minus the height of the door. Alright, that's how we'll get that distance. That distance is equal to 30.45 meters. This is how much the ball needs to travel from its maximum height to reach the top of that door. Alright, so we need to find that initial V, that Vi, the velocity at the top of the door. Now we're going to do that. We're going to say Vf squared is equal to Vi squared plus 2a delta y. Now we're still taking downwards as positive. Alright. Now this Vf squared is essentially what we're trying to find. Alright, so we're just gonna leave it. Vf squared is equal to Vi, our initial velocity at this max height is 0, plus 2, our acceleration is pointing downwards, so that will be positive, and then our delta y, well, we're going downwards, right? This distance is downwards. This distance here is pointing downwards, which is also in the same direction as the acceleration. Right, so that is 30.45, and doing some maths, we're going to find that Vf is equal to 24.43 meters per second as the velocity above the door. This is above the door. Now we already have our Vf, we already have our A, so we can find our time t. Alright, so Vf is equal to Vi plus A multiplied to delta t. Vf, the velocity at the ground. This is our velocity at the ground. This is at the top of door. Our Vf is equal to 25.18 as we got in the previous question. Our Vi is 24.43, and this is pointing downwards. This is also pointing downwards. Alright, and our acceleration is 9.8, and we're trying to find our delta t. Alright, cool. Alright, so doing a bit of maths, we find that the time it takes is 0.077 seconds, which can be rounded off to 0.08 seconds. Alright, question 3.3 is asking us to draw a velocity versus time graph for the motion of this ball from the moment the ball is thrown upwards until it strikes the ground. Use the ground as the zero reference. Alright, now we need to clearly indicate the following on the graph: the velocity with which the ball was thrown upwards, the time taken by the ball to reach its maximum height, and the velocity with which the ball strikes the ground. Okay, so velocity versus time graph. Obviously, you're going to use a ruler to draw this. I'm just doing it to show you what needs to be done or how I would do it. Right, so on the x-axis, we're going to have time. Time will be in seconds, and then on the y-axis, we're going to have velocity, and it will be measured in meters per second. All right, coolio. Now, things to note. All right, when ball is launched up, we took downwards as negative throughout this whole question. Downwards was positive, sorry. So if the ball is launched up, that means that velocity will be negative. And then if the ball is going down, that means our velocity will be positive. But since we took downwards as negative, what does that mean for our acceleration? right? Our acceleration AY, which is 9.8, that means it's positive throughout, right? And our acceleration is actually the gradient of our graph because it's constant and that's the only force that's acting in free fall. All right, cool. So just those things out the way. All right, so what are the times? The times are, we have a time for 1.22 seconds. That's the only time we have. And when it strikes the ground, it's moving at a positive or negative. It's moving at a positive velocity because downwards is positive. So that means that 25.18 is above the x-axis, and it is initially launched with 12 meters per second, but that is going up. So that is going to be a negative velocity. And all you have to do from 0 seconds, it goes to a maximum height um, well, we calculated that maximum height, but at the maximum height, the velocity is 0. So that means at 1.22 seconds, the velocity is 0, and then it's just going to increase. Obviously, in your case, this has to be a straight line to show the constant gradient, and it has to be positive as long as you took downwards as positive. So that's your graph, and that's your question 3. Please comment if you have any questions, or if you would like us to do more questions like these, or if you didn't really understand anything that we did in this question paper. Thank you so much for tuning in. Have a great one.